A warm welcome, ladies and gentlemen, here in Graz, Austria, at the headquarters of Bruker Licona. My name is Kevin Matti, and I'm a senior application expert in Bruker Licona. And today, I want to give you 5 steps to increase your competitive advantages based on precision dies. Let's start. If we are talking about stamping, punching, pressing, bending, or whatever, we are talking about tools you can see on the screen right now. These tools can vary in form, in size, and also in the shininess of the surface. So it's quite a big challenge for metrology to measure exactly these tools. But there are also big challenges for the manufacturers of these tools. So most of the time, the cut file does not look the same as the manufacturing part. This can be caused due to vibrations, a worn tool, machine performance, or whatever. So, no deviations in the shape-giving geometry in respect to a datum is the challenge for the metrology. The tolerance over here are most likely in a single-digit micron. Traditional technologies can solve this task partly. So either the measurement time takes too long, we have only 2D sections, or we have a certain kind of trade-off between accuracy and resolution. I figured out 5 steps for your competitive advantage. So first, let's talk about the accuracy. When we are talking about the ISO-GPS and freeform shapes, it's most likely a profile of a surface over the whole stamping die surface in respect to the datum. You can see it here as it should look in a technical drawing. This means we have multi-directional tolerance lower than 0.01 millimeter. When we are going to measure these parts, we have measured points and we have the nominal surface. So the measurement point has to be within a certain tolerance band in relation to the nominal surface. For the measurement device, it means that the measurement needs to be multiple times higher in accuracy over the full volume of the die. And of course, we have to measure this complex shape with a high point density. With our micro CMM, we can exactly reach this. For local area measurements, we have an E-uni stationary maximum permissible error of 0.15 plus L divided by 50. This means for a 1 millimeter height step measurement, we have a maximum error of 170 nanometers. Over the whole spatial volume of the micro CMM, this means 310 to 310 to 310 millimeters in a cube. It is an E-uni translatory MPE of 0.8 plus L divided by 600. As an example, when we are talking about a length measurement of 30 millimeters, we have a maximum error of 0.85 micrometer. You can see also on the screen the high point density we can deliver with our advanced focus variation technology. This means that small features can be measured with a very, very high accuracy. And additional, it's also possible to measure the roughness on your stamping dies. The second point, of course, is the smart operator experience. As I have been to a lot of customers outside in the field, we are also talking about the technology, but also how to use this machine. So it has to have a modern, intuitive user interface, and it has to be an ease of use with almost no training. And for me, it's also very important the excitement for the operators, because it's often in the industry that also the guy who is or the girl who is at the manufacturing machine is using also our measurement devices, and he cannot even be expert in these two complete different areas. As you know, hopefully our software and our metrology platform MadMax, we have a digital twin with measurement simulation and a collision detection. But that's not all. To be safe, you have to have also a smart measurement planning. And it's also important to have a clean and simple user interface. The digital twin allows us in the metrology platform to directly set our measurements in the digital twin. So the identical duplicated measurement device, even if it's a micro CMM or a G6, is integrated in the software. And the axes have a live synchronization between the real and the digital twin. For smart operator experience, it's also important to have an offline planning. So the downtimes of the production and of the metrology device is minimized. You can directly start with your measurement program after the cut is finished. This is, in my opinion, a very important step to be more efficient when we are talking about metrology. So what is usually the plan? Usually you're doing a cut import and an alignment. You start with a measurement planning, you start with an offline simulation, and afterwards you do the evaluation and the measurement, and of course the reporting is very important. But with our solution, which I will show you afterwards in a video, it's quite an ease of use to just do the import and the alignment and afterwards the reporting. The third point is the automation. So the solution needs to automate recurring measurement tasks, and it will free up the metrology expert for analysis. So if you have a detailed problem, your metrology expert will have more time to analyze the problem in deep. At the left side, you see for our vertical solution, according to the precision dice, you see the workflow. You have to load the cut data, you have to align it, you have to create the datum, you have to create a smart PMI, and then you have to click on measure. If these measurement tasks reoccur, you have a one-button solution already. But we are going one step further. We also deliver pick and place in this industry. The pick and place is a collaborative robot which can directly insert your parts into the metrology machine. You have a manager software where you just say, at this place you have to act with this measurement program. So this is a very important step when we're talking about efficiency. For example, in the afternoon, your metrology expert teach in the whole palette of the pick and place system, goes into his free time, and afterwards in the morning you have all your measurement results. But Bruker Licona is also integration ready. With TCP/IP or Modbus, we already solved projects where we have insert our micro CMM directly into a manufacturing cells. But I talked about PMI. Do you know already what a PMI is? PMI means product manufacturing information. Everything and much more what is shown on a technical drawing is directly added to the CAD file. This gives us a really big advantage in metrology because already the construction side gives us the information what we have to measure. And of course the PMI is a subject to ASME and the ISO industry standards. So with a PMI, you bring your automation to the next level. From the workflow I told you before, you have to load the CAD file with the PMI. Either you have also the offset data from your manufacturing machine and you press on start. And this is, I think, already the solution the industry needs. So start with your PMIs, bring us your precision dies, and we will have a one-button solution for you. But it's always also important to have a trusted solution. We are developing our solutions with industry leaders. As you can see here, some companies which are doing exactly the former explained steps to integrate their metrology efficient in the company direct. I will give you some examples. Over here, it's very important to have a high point density. You have a contour inspection, you have to have the outer surface for the datum, and then you can get a nice report, in this case, over these 3 lines from this precision die. Another example is shown over here, so it looks completely different. We have a full measurement of the whole surface which is needed, and we do a CAD comparison directly in our software. But from the theoretical part, it's always the explanation and the reality. So I want to show you now with a video how it looks in real. Have you seen how easy it is to use this solution for your parts as well? So to sum it up, you have to load the cut, you have to specify the datum and the verification, which means actually the measurement strategy will be done directly from the software fully automatically. Afterwards, the same with the PMI. You add the PMI as profile of a surface. You just select the batches on your CAD file which should be measured. You add the tolerance and the verification. So the measurement is done totally automatically. The result will look similar to this. So check the deviations directly in the live view without any step further, and you have also the possibility to click on certain positions where you want to have the deviations, where you want to have the deviation labels. So let's sum it up. 5 steps. First of all, the accuracy. With our micro CMM, I think it's not a problem. We have the smart user experience where the hard and the software comes from a single source, made in Austria here in Graz. The automation with MapMax and Pick and Place or an integration in your cell, no problem. PMI, I think this is the next step for you to automate your metrology systems. It's an integrated routine already in MapMax. And of course, the trusted solution. So developed with industry leaders outside in the field. And we are really looking forward to get your application. Thank you.